Assalamu alaikum students, welcome to Students Platform 82. Today we'll be learning chemistry of class 9-10 NCTV syllabus. So, let's get right on to the topic. Today's chapter is the 6th chapter of the class 9-10 chemistry textbook, which is concept of mole and chemical counting. So, let's see the topics of discussion for these lectures at a glance. The topics are concept of mole, atomic and molecular mass, molar volume, molarity and solutions, molecular and empirical formula and percent composition, chemical equation and balancing, stoichiometry, limiting reactant and yield. For today's lecture, we'll be confined to the topics given in front of your screen. And that is concept of mole, atomic and molecular mass, chemical equation and balancing. And last but not the least, stoichiometry, limiting reactant and yield. Yield, that is yield percentage. So let's get on with mole. What is mole? When we hear the term mole in chemistry, we understand a particular amount of substance. A mole is a unit of chemical measurement. The short form for mole is mole, that is MOL. 1 mole of something represents 6.023 into 10 to the power 23 number of that thing. Such as when somebody says a dozen books, it means that there are 12 books. Similarly, when somebody says there is 1 mole of books, that means there is, grammatical mistake, there are 6.023 into 10 to the power 23 books. So, this number 6.023 into 10 to the power 23 is also known as Avogadro number. So the definition of Avogadro number would be simple as the number 6.023 into 10 to the power 23 is known as Avogadro number. Simple. Now, in case of atom, 1 mole of atom refers to the atomic mass of that particular atom, and in case of molecule, 1 mole of molecule equals to molecular mass of that molecule, which is very simple to understand. But now, first we need to understand by atomic mass of an atom what do we actually mean, because as we know that atomic mass of an atom is actually unitless. Though we know that it is unitless, it does have an unit, which is atomic mass unit, which we shall be learning later. For now, atomic mass of atom equals to the relative atomic mass number in grams. That is, it is actually that mass but expressed with a unit of gram. And molecular mass of molecule will be equal to relative molecular mass number in grams. For instance, 1 mole carbon atom will equal to its atomic mass and will equal to 12 gram. Here 12 is the atomic mass number of carbon. Now it is expressed as gram, so it is now the atomic mass of carbon, which will also equal to 6.023 into 10 to the power 23 carbon atoms. That means 6.023 into 10 to the power 23 carbon atoms weigh as much as 12 gram. Similarly, 1 mole of water molecule will be equal to the molecular mass of water, which is 18 gram, and will also contain 6.023 into 10 to the power 23 water molecules. I hope that you have got the concept of molecule. I hope that you have got the concept of mole. Now, on to the next topic, atomic and molecular mass calculation. As we know, molecular mass equals relative molecular mass number expressed in gram. So, molecular mass of molecule will equal to sum of the constituent atomic masses after being multiplied by the respective number of atoms. We can understand this through an example, that is, molecular mass of CuSO4.5H2O, which is actually copper sulfate pentahydrate, and penta refers to 5H2O. Here, the molecular mass of copper sulfate pentahydrate will equal to sum of the masses of copper, sulfur, oxygen and hydrogen, as these are the constituent atoms of the chemical compound. Here, the number of copper atoms, as we can see, is 1, and its value or atomic mass is 63.5 gram, and the next atom, which is sulfur atom, it is 1 in number and its atomic mass is 32 gram, Then here we have oxygen atom. We can see that copper sulfate has 4 atoms of oxygen and pentahydrate has 1 into 5 atoms of oxygen. So total there are 9 atoms and they will equal to 9 into 16. 16 is the atomic mass of oxygen atom. In total there is 144 gram of oxygen atom. Then we have hydrogen. There are 5 into 2, that is 10 atoms of hydrogen, and we know that the atomic mass of one hydrogen atom is 1 gram. Therefore the total mass of 10 hydrogen atoms will equal to 10 gram. Therefore the total molecular mass of copper sulfate pentahydrate is 63.5 plus 32 plus 144 plus 10, which equals to 249.5 gram. Now for 1 mole of water molecule, that is 1 mole H2 equals to 18 gram, and we know that we can also find out the molecular mass very easily, that hydrogen has 1 hydrogen atom equals to 1 gram, so 2 equals to 2 gram, and oxygen atom equals to 16 gram, therefore total 18 gram. Simple. This one, copper sulfate pentahydrate, is a bit complex, and H2O is a simpler version of the previous one. Now 18 gram of water equals to it actually contains 6.023 into 10 to the power 23 molecules of H2O. Therefore we can find out how much one molecule of H2O actually weighs. That is, we shall divide 18 by 6.023 into 10 to the power 23, or we can, let's just for the lecture call it as the Avogadro number. The result will be 2.989 into 10 to the power, sorry I have missed the 10 here, it will be 10 to the power inverse 23, which is a really low amount. It is not understandable to the naked eye because we shall not see anything, but there is something scientific or more microscopic which we shall learn later. Again, 1 gram of water molecule equals to the Avogadro number divided by 18, which is 3.346 into 10 to the power 22 molecule of H2O. That means 1 gram of water also contain a very high number of molecules of H2O. Now let's get on to the next topic, that is chemical equation and balancing. Balancing part is quite simple if you can understand and know the tricks behind it. So first of all, change in substance resulting in new properties giving up its own properties is chemical change. Now the process which will result this chemical change is known as the chemical reaction. Now finally, the short expression of this chemical reaction using symbol, signs and formula is chemical equation. So it is very simple. By definition, we can say that chemical equation is a short expression of chemical reaction which uses symbol, signs and formula. Now on to balancing of chemical equation. The first point is that the reactants will be on the left and the product or products will be on the right. Usually reactants are more than one if it is not a decomposition reaction, which we shall learn in chapter 7 of chemistry book. And product is usually one or it can be more. That's up to the reaction. Plus sign will be used between the reactants if more than one and products if more than one, and equal sign will be used between the reactants and products, which will show that the reactants produce the products. The number of individual atoms on both sides is to be equalized by multiplying with required number so that the reaction is actually balanced. An arrow sign can be used if the equation is not balanced. If the equation is not balanced, for example, during examination sometimes we write the equation but we are not able to balance it, either it is hard or we have less amount of time. In that case, we shall just use the arrow, which will be a good way of presenting the equation, which will not be wrong, rather it will be okay, but just not balanced. The physical state should be mentioned, as it is very important to know in which state the reaction takes place for individual atoms or molecules. So for solid S is the physical state, that is S is short for solid, L is short for liquid, G is short for gaseous, AQ is short for aqueous. And you should be very careful about the word aqueous, which is a bit uncommon but common among the chemists. And aqueous refers to the solution where a compound or a chemical substance is dissolved. So now, in the reactions involving heat change, that is there will be heat production or absorption in those reactions, we must mention those by using H or delta, which I'll be discussing in the next point. That is, when heat is applied in a reaction, delta is used above the arrow. I shall be explaining this through the following examples. So here we can see a very simple equation, that is the equation of water molecule, that is H2 plus OT equals to H2O. So we can see that there are 2 hydrogen atoms on the reactant side and 2 oxygen atoms. On the product side there is 2 hydrogen atoms and 2 oxygen atoms. So since here the number of oxygen atoms is low, so we shall multiply it by 2 so that the number increases. And we can see that the number of oxygen atoms on both sides are equal, but the number of hydrogen atoms is less, so we shall multiply it by 2, and now there are 4 atoms of hydrogen on each side of the equation. That is done. Again, in some cases you shall see that the chemical reaction doesn't need to be balanced, because it already gets balanced during the first try. That is, carbon plus oxygen molecule equals to carbon dioxide, which is actually balanced, because we can see 1 carbon atom on both sides and 2 oxygen atom on both sides. And here you can see, as I said earlier, the physical state are to be mentioned. Here you can see S for solid, G for gaseous, and the resultant is gaseous. It is very important to know the physical state, as we can determine the product's physical state after the reaction. That is a hypothetical understanding. Now let's come on to a complex balancing of equation. Here you can see that aluminum oxide is added with hydrochloric acid, which results in aluminum chloride with water. So first of all, you can see that it is a bit complex, so we shall do it step by step. So you can see that first of all, let's think about aluminum. Here there is 2 aluminum atom, and here is, sorry, on the product side here there is aluminum atom, which is 1 in number, so we shall use a 2 here, and therefore now there are 2 aluminum atom and 2 into 3, 6 chlorine atoms. So we can see that the number of aluminum atom on both sides of the equation is balanced, but for chlorine it is not balanced. So now we shall use, as we can understand, that we should use a 6, that is 6 is to be multiplied with hydrochloric acid, so that it results in 6 chlorine atoms. Now chlorine is balanced on both sides, but we can see that there are 6 hydrogen atoms on the reactant side, but on the product side there are only 2 hydrogen atoms. Therefore these are not balanced. To balance this unbalanced number of hydrogen atoms, we shall again use a number, we shall again use an integer to multiply the water molecule. I have made a bit of mistake here. It should be 3. My mistake, I have given it 6. Here the number to be multiplied with water molecule is to be 3, so that 3 into 2 there are 6 hydrogen atoms and 3 of oxygen atom. And we can also see that if we multiply it by 3, the number of oxygen atom on the product side will be 3, and on that of the reactant side it was 3 and it remains 3. So for my mistake, it will be 3 here. 3 is to be multiplied with water molecules number. I hope your confusion will be clear. Sorry for the problem. Now on to using the delta sign and heat change. As I said before, when heat is applied in a reaction, delta is used over the arrow. This delta is replaced over the arrow, as heat is a catalyst over here. And what is a catalyst? Catalyst is a particular substance which helps to speed up the reaction, or it helps to complete the reaction. It is not a reactant, whether it is an outside effect, and not an outside effect, actually it is a kind of outside influencer. Yep, that is a good word. An outside influencer which will result in complete production of the required products. And again, it is to be placed over the arrow, not like this. Actually, it should be a bit more to the right to where it is placed currently. Now, on to this point, that heat production or absorption to be mentioned in heat change reaction. So we should use a particular sign to express this heat change. That is, we can see in this reaction of nitrogen and oxygen, where it produces nitrous dioxide. Yep, that I'm right. Perhaps there is a bit confusion. Still, we can see that here plus delta H. Here we can see that when nitrogen is added, or nitrogen reacts with oxygen, it produces NO2, and plus delta H equal to positive 180 kilojoule. Now, just for your understanding, delta H refers to the heat change. Since it is positive 180 kilojoule, that means positive 180 kilojoule has been absorbed in the formation of this product, that is nitrous dioxide. So we should be learning more about delta H in chapter 7 of your chemistry book. Now let's get on to the next topic, which is stoichiometry of a reaction. So what is stoichiometry? A branch of chemistry concerning the measurement of products from amount of reactants and vice versa, and that is also the measurement of reactant from the products. So that is stoichiometry. Now, information regarding mole from a chemical equation is a stoichiometry of that reaction. For instance, we can understand that 2 Mg, that is magnesium atom, is added to 1 molecule of oxygen. That is, magnesium reacts with oxygen and produces 2 magnesium dioxide molecule. Not 2 magnesium dioxide, it is actually 2 magnesium molecule. Magnesium dioxide mole, 2 moles of magnesium oxide. Sorry for the mistake over there. So it is very important to balance the equation before finding out the stoichiometry of the reaction. So here the stoichiometry of the reaction is as follows. 2 mole of magnesium atom will result in 2 into 24 equal to 48 gram, as 24 is the atomic mass number, or atomic mass of 24. Again, the atomic mass of oxygen molecule is 32, and here only one molecule of oxygen, 1 mole of oxygen molecule is present, so it is 32 gram. And as I said before, 2 MgO refers to 2 magnesium oxide molecule mole, 2 mole of magnesium oxide molecule, and therefore here the amount of magnesium oxide is 24 plus 16, that is magnesium oxide's total molecular mass, that is 24 plus 16 equals to 40 multiplied by 2, as there are 2 mole is 80 gram. I am again telling you this, that when you see 2 before a particular chemical substance, it refers to the mole of that chemical substance. As we can see here, 2 Mg refers to 2 magnesium mole. Here there is a 1, but it is not required to write 1. So here we can see 1 mole of oxygen molecule. Again, similarly, here there is 2 mole of magnesium oxide molecule. So I hope that is clear. Now, why do we need the stoichiometry of a reaction? This answer is simple: to find the required amount of individual reactants and products. We can find out the amount of individual reactants and products from stoichiometry, and if we are given a particular amount of any of the two, for example, we are giving a particular amount of reactant, then we can easily find out the value or the amount of product which will be produced by using the reactants. Now on to the next topic, how to find limiting reactant. It is very interesting that the previous topic, that is stoichiometry of reaction, is very much related to limiting reactant. Limiting reactant refers to the reactant that finishes before the other reactant finishes. It might be a bit hard for you to understand, but it is actually very simple. As we can see, as the reactant finishes up first, so the residue of the other reactant remains and the reaction stops. So that reaction which finishes up first is a limiting reactant, because due to finishing up that reactant, the reaction is stopped. Although the second reactant, here we're considering that there are two reactants, the second reactant is there, due to the finishing of the first reactant, the reaction stops. Therefore, it is the limiting reactant. Now, we shall understand it by a few examples. The first example, say 4 oxygen molecules are added with 4 magnesium atoms. What is the limiting reactant here? For this, we need to find the stoichiometry of the reaction first. As we know, 2 magnesium atom reacts with 1 oxygen molecule to form 2 magnesium oxide molecule. So from here we can easily use the unitary method that we learned in mathematics years ago, and we're still using it. That is the most fun thing to do, and that is the most interesting way to solve this problem. Here we can see that 2 magnesium atom reacts with 1 oxygen molecule. One will react with this one, and 4 magnesium atom will react with this one. So we can see that the given oxygen amount is, here will be an I have mistakenly removed that. I don't know how or why. Oxygen atom is more than required, so it will be residue, and magnesium will finish up first, and so magnesium is limiting reactant. Let me explain this a bit more. Here you can see the 4 magnesium atom reacts with 2 oxygen molecule, and here there are 4 magnesium atoms, okay, but there are more number of molecules than required. Here we can see 4 oxygen molecules, but we need 2 oxygen molecules, so 4 magnesium atom will react with the 2 oxygen molecule, but the remaining 2, that is 4 minus 2, 2 more oxygen molecule will remain, and so it will be the residue. But the residue is not the limiting reactant. The limiting reactant is the one which finishes up itself first. Here 4 magnesium atom finishes up itself first, leaving 2 oxygen molecules as residue. So magnesium is the limiting reactant here. We shall be using this formula, this chemical equation of magnesium oxide, to explain a few more concepts. Another example, here we'll be using gram or atomic mass, or the weight. I should actually say mass, as weight and mass are different terms, as you have already known by now. So let's say 5 gram of oxygen is added to 5 gram magnesium to react and produce magnesium oxide. So what will be the limiting reactant here? At first, again, we need to find the stoichiometry of the equation. Here 2 mole magnesium atom reacts with 1 mole oxygen molecule to form 2 mole magnesium molecule. So the molecular mass 48 gram, 32 gram and 80 gram. Therefore, similarly we shall do the unitary method, that is 48 gram of magnesium reacts with 32 gram. 1 gram of magnesium reacts with 0.66 gram of oxygen. Therefore 5 gram would react with 3.33 gram of oxygen. Here again we can see that 5 gram is used to react with 3.33 gram, but the given amount of oxygen is more than required. Again, it will stay as a residue, and magnesium will again be the limiting reactant. We can also do the opposite method. We can also use the opposite method, but this is a good way to do it as well. In another method, we could use oxygen, that is, we shall use unitary method for oxygen, and we will find that for 5 gram of oxygen we need more than 5 gram of magnesium. So what will that mean? That means that the required amount of magnesium is more than the given. In that case, magnesium will again finish itself up first. Similarly, as stated here, magnesium will again be the limiting reactant, and the same goes for the upper example as well. You can also use oxygen in the neutering method rather than using magnesium atom. The result will be the same, just a bit in a different way. We might have to write it in a passive way. That is the difference. Now let's get on to the next and perhaps the last topic of this lecture, that is yield percentage. So what is yield? Yield is the amount of product formed from the reactants during the reaction. Sorry for the mistake. I don't know why this happened. Well, I hope you will be understanding this. I wanted to write that yield is the amount of product from reactants during a reaction. Actually, it should be that formed, or amount of yield is the amount of product formed from the reactants during a reaction. Well, but then using this definition, you can also use that yield is the amount of product which we are expected to get from the reactants during a chemical reaction. You can also use the definition of your textbook. These are easier, and this one is applicable. I'm sorry for the grammatical and vocabulary mistake. So yield is lesser than expected, as not all reactants completely react. So yield will be less than expected. What does that mean? Using the stoichiometry of a reaction, we can hypothetically find out the expected amount of product, but in reality that does not happen. Yield refers to the amount of product produced in reality, for which yield is lesser than the hypothetical value of the amount of the product. As while in a reaction, all the reactants will completely react, or due to some reason the amount of reactants doesn't produce the required amount of product. Usually it does not complete the reaction, for which yield is usually lesser than the expected amount. And for yield, we should always find it out in percentage. That is, the formula is the given amount by the required amount, and this required amount is actually the hypothetical amount in percentage. So let's make it clear through an example. That is, say 2 gram magnesium reacts with necessary amount of oxygen to produce 3.25 gram magnesium oxide. What's the yield? Here I haven't mentioned the amount of oxygen, as we do not need it. I could also reverse the question by saying that suppose say X amount of oxygen reacts with Y amount of magnesium and produces 3.25 gram of magnesium oxide. Find the amount of find the yield. So yeah, I could do that, but here you can only mention one of the amount of one of the two reactants. So we shall go on with the example. First, we need to find out the stoichiometry of this reaction. Here 2 mole of magnesium atom reacts with 1 mole of oxygen molecule, as we know from the previous examples, and results in 2 mole of magnesium oxide molecule. So we can also use the UT method in this math as well, in this mathematical calculation as well. So 48 gram of magnesium produces 80 gram of magnesium oxide. Therefore 1 gram produces this much and 2 gram produces 3.33 gram. Here we can see that 3.33 gram is the hypothetically expected amount of product, but in reality it produces 3.25 gram. Therefore the formula for yield, the given amount, which is 3.25 gram, and the expected hypothetical amount 3.33 gram, as we can see, it is always lesser than that of that the given is always given or produced amount of product is always lesser than the expected amount. Then we shall do multiply it by percentage, or represented in percentage, which is 97.6%. Well, in reality, it cannot be actually 100%. At most, it might go on to 99% or a bit more, but in reality, it is never 100%. So, now here is the short or brief description about the points, about the topics of discussion I mentioned earlier. Thank you for listening, and this is the first part of my lecture on chapter 6. I shall inshallah continue this lecture in near future. So I hope you have understood all the points I have mentioned clearly, and feel free to pause the video at any moment and use those notes as you can. And if I have made any vocabulary or grammatical mistake, please do correct it and use it at your convenience. I shall be very happy if these notes are used by you in your examination or such, that is, if these come to your help. So thank you for listening once again.